So welcome to this session with us, DataRobot, where we will, in 20 minutes, show you how you can become an AI-driven organization. I will just present the company and what we do, why we exist. Not more than 3 minutes, I hope. So that one hasn't started yet, so that's good for me. And then Håkan will do a demo of the platform. So hopefully you will be as blown away by that as I was the first time I saw that platform. But DataRobot, who we are, just a few facts. So we are a company founded in Boston, US, 2012, by data scientists. We are still very much a data scientist company, so half of our, we're around 500 employees at the moment, and more than 200 are data scientists. We are well funded and well used, and we are still put a lot of pride in that we have some of the best data scientists in the world in our company. So why do we exist? What do we do? I assume now that everyone here knows about data science and machine learning, and some of you are probably working with analytics problems, and you see that there is a real demand for the market, for these models in the market right now. So the opportunities, AI opportunities are enormous, and we are no longer in a stage where we just sort of play around with this. This is real now, so the market is, and your customers are probably asking for this as we speak. But the supply is still a challenge. So there's a huge gap between what organizations can supply in terms of data science and what the market demands and where the opportunities are. So what you could do then is to hire more data scientists if you can afford it and if you can find them. But a better way, we think, we are convinced, is to apply automated machine learning to complement your very skilled data science team, and then be able to scale all of these predictions that you want to do in your business, and start the journey to become a really AI-driven organization. So the first thing you do is that you make your data science team much more productive than they are today. The next thing is probably that you democratize these predictions in your organization, so not just these very skilled data scientists, but also the business analysts in your organizations who know your business and your data really well, but are not really the coders and the mathematicians. And then the next step is then to really, turn this into a factory and really become an agile and very, using these predictive models in pretty much everything you do in your organization. So this is who we are, and hopefully Håkan will be able to show you how you can start this journey, how you can use DataRobot as a platform for your automated machine learning.
Yes, I can. As Paul mentioned, we're pro AI-driven enterprises. So what we try to do is turn machine learning into a factory, in a sense. So I work for a group called AI Services inside DataRobot, and what we do is help clients, first off, to scope business problems that their organization has. So we generate these long lists of business problems that exist within a business. For each one, we attach or estimate a business value that belongs with that business problem. Also, we make some sort of estimate of the feasibility of solving a particular business problem. So feasibility is, is there data, or do we have the right people in place? Even if we have those two, perhaps deployment will be difficult because the change management required to deploy. The observation that I have of this process with every business that I've worked on so far, or with so far, is that there are too many business problems to solve, and you typically end up leaving millions on the table because you have to focus. The bandwidth of each company is, let's say, the top 3 business problems, and you work your way through those. But there's always several more that leave opportunities to save millions that are just left. It's quite frustrating. So the idea with DataRobot then is to turn this into a bit of a factory process, as mentioned. So what we do is pick the first one and work our way through. And the way DataRobot optimizes this is by making the model build process very fast and the technical model deployment part very fast. So you can work your way through this list and become an AI-driven enterprise a lot faster because you're able to take a large chunk of your business's problem and solve them using AI in very short order. So let's get the beginning of the journey starts with one problem that can be solved with data. So let's say that maybe I shouldn't have skipped out of that yet. Let's continue here. So let's imagine now a situation where we've generated a long list, and the top problem for our business is related to customer loyalty. The reason I picked that topic for this talk is that every business has a customer loyalty problem. A lot of industries, like telecoms, for instance, where it's very fluid, unsecured personal loans, they're particularly prone to this because it's easy for customers to jump. So here's a business problem. What my team would do with clients after this is to dig a bit deeper into the problem and try to understand what customer loyalty means. So for a telecoms company, for instance, perhaps it means that they turn off their account and move to a competitor. And then we would discover a data set that would allow us to model the behavior that we're looking at. So that's the leaping off point for this demo. I've sort of skipped over a part about defining problems and extracting data in the interest of time, but let's now say that we've defined the problem, and you guys can see this. Jolly good. Let me make a more palatable background for you there. So let's now say that you're a telecoms company and you have a problem with people leaving your business and going to competitors. You have assembled a data set that contains a whole bunch of accounts and their details. So this first guy, the account state is Kansas. The account has been around for 128 months. The area code is 415, which puts it in the Bay Area in California. This account does have an international plan. Other interesting things. So this customer has called customer service once. Here is just a string of everything that's contained in his terms and conditions. And then crucially, we have a target variable, which records whether or not that customer left in some target window. So this first customer here, he did not leave. This customer number 11 here, he did leave at some point. So another thing you can look at, or an observation you can make at this point, is that maybe reasonably, a person who only felt the need to call customer service once didn't leave, but a person who felt the need to call 4 times did in fact leave. So we have a data set, and the first step of this process then is to build models using these variables to predict something about customers leaving. There's a number of ways of getting data into DataRobot. The way we'll use now for demo purposes is drag and drop the data in, but you can also connect automatically through to a SQL database, or you can connect to Hadoop and so forth. So there's a lot of different ways you can do this. Let's drag that bit. We'll drag and drop it in, and then we hope that the internet is decent. Otherwise, there is a period here where you wait. So yeah, the data uploads, and then there's some sort of initial EDA, we call it, exploratory data analysis, where the DataRobot figures out that the state variable is a categorical variable with 51 categories. The number of customer service calls is a numeric variable with an infinite number of values potentially. So we can see all that down here. Yes, it's reasonably good. So yeah, state has been accurately read as a categorical, and here is all the values. So these should be all the states. As I said, number of customer service calls is numeric and so forth. So the idea with here is that this stuff should reflect the Excel, the stuff that's already known to be in your data set. The tariff plan here is text and so forth. So as mentioned, what we're trying to do is make a prediction about the future, about customers leaving our business. The idea then is to, off the back of that, deploy and have some outreach teams, for instance. I've worked with one Swedish client where off the back of our predictions, we have customer service teams that reach out to clients, and offer certain incentives that are also optimized using DataRobot to convince them to stay. Whatever that might be. Maybe I'll not go into too deeply into that. But the first step is to predict. What would we like to predict? We want to predict which customers are going to leave. DataRobot now tells me that there are 400 people in this data set that did leave and 2,800 odd that did not leave. So a total of 3,000 rows in the data set, which is quite small, but it's only for demo purposes. Yeah, so then there's an inviting start button, which means you can start. And by start, it means it's going to start generating a whole bunch of models for you. So it'll generate a long, long list of models that it wants to try. Then it'll try the first one, build a model on the data that you've provided it with, and then evaluate it, and then it will do the next one, and it will do the same process. And in the process of doing so, it'll arrive at the model that's optimal in some sense for the data that you've provided. So that's the story of that. So I'll start this process off. We'll talk some more while it's going, so it takes a few minutes. So the first thing, maybe the best way to do this is to do this. So yeah, I mentioned that it evaluates models. So what it does is it takes a model. Actually, we call these blueprints because they contain both feature engineering steps and models. So it's not just a model, it's those two packaged together we call a blueprint. And it trains these things up and ranks them. So the question is then, how does it rank them? Actually, I've had this question at least twice today. So how do we rank them? We've provided it with historical data. We take the first half and we train the model on it. And then on the second half, we know, because it's historical data, we know what happened. We know what customers are going to leave. And we can also make our predictions, so we can compare our predictions with what actually happened. And so we're able to compute exactly what the errors we're making. So this first model that's come out has an error of 0.38. And so it's currently the winner on the leaderboard here, but only because it's the first one and it's not actually going to win eventually. So it's training these two in parallel, so quite slowly. So if you want to add a whole bunch of more workers, you can train. I've only got access to 20, but in principle, you can have an infinite number of these. So now there's training 20 of these in parallel. So basically the idea is that it'll spin up a whole bunch of models for your problem, and taking a whole big chunk out of what would normally take months. So the model training has really been sped up a lot, and this supports this AI-driven enterprise idea, because now instead of spending months developing one model, I can spend a week, and then I can get to the next problem and generate another bunch of business value. The other thing that people don't necessarily think of very hard when they see that machine learning can be speeded up like this is the effect that it has on your stakeholder management. So stakeholders get bored if something takes 3 months. If you can do a week and then come back with a model, then people are a lot happier to iterate in that way, because the conversation continues and it's seen that you're delivering value continuously rather than something that sort of disappears into a rabbit hole of research and so forth. Anyway, so that's the story of the models are training up, but it's going to take a few more minutes here. So I've got one cooking style, got one that's finished. Top model is gradient boosted trees classifier from a sklearn package. So a lot of these are from open source packages. This one is from sklearn, as I mentioned. What else we got in here? XGBoost, everyone's heard of. This is everyone's favorite algorithm. There's a couple of bespoke DataRobot ones. So this one's developed in-house and IP. Something from an R package, and so forth. So one initial step that we always go through with my clients is we look at some things to inspect the inside of the model. And the first thing is really to really understand what the most important variable, or what the model considers to be the most important variable, and that's measured by feature impact, which is here. It's a great thing to check, because it gives you a sense check from the business that what you're doing is sensible. If your top variable here is something that the business completely wasn't expecting, then either maybe your data's broken or your understanding of the business problem is slightly broken. So either way, you can learn something and iterate. So the first one here is the number of customer service calls, which is, I've seen the story before, which is why I've been talking about it earlier in the story. So customer service calls is very important. In the international plan is very important. whether or not an account has an international plan. If you wanted to dig a bit deeper and see what the relationship between the input variable and the target variable is, you could look at feature effects, which tells you what exactly the relationship between the target and the feature. So for instance, the number of customer service calls here, if you have 0 up to 3 customer service calls, or then the chance that you leave the company is not that high. But as soon as you get to 4, the company's really in trouble, and that customer may leave. Similarly, with the international plan, if a customer does not have an international plan, the probability of them leaving is small. The people with international plans are far more of a flight risk. Another place we can see this is so we have a number of ways of inspecting models. One is related to text variables, which I also alluded to earlier. And this one is, so the text variable was the stuff that's contained inside your tariff. That can also be passed inside DataRobot. So here's a word cloud of everything that's contained in that text variable. In particular, we see that, again, the word international, it's not occurring very often, but when it does, it's highly predictive of the customer disappearing. The word charging appears slightly more often, but it's predictive in the opposite direction. So a customer with the word charging in their tariff is predictive of them staying. Not 100% certain what that's all about. But so 3 minutes. Let's see, where should we hop to next? So with that amount of time, I think I might have to do this. Yeah. So I mentioned that it's a 2-stage process, and we save time in 2 places. The first place is the model development, which I've shown you, and it's extremely fast compared to the manual approach. The other place is deployment. So typically, this is also a huge problem for machine learning. So 99% of models go to the deployment stage and just sit there in a queue, typically in a different part of the business, and don't get deployed. So we've also automated as much as possible this part. So the deploy, we have a model API that we can deploy. So here's this top model here. If I wanted to generate an API that eats input data and responds with the probability of a customer leaving, I press this button, and then I deploy the model, and then it thinks about it for a little bit, and then it's now ready. So the API is ready, and if I wanted to ping it, it would respond with the probability of leaving. If I wanted to integrate into my system, I take this code and I drop it into whatever front-end systems I would have. So for instance, this client of ours, they could take this and put it into their customer-facing or customer service systems, and those systems would be able to surface a probability of leaving. And based on, let's say, if the probability is 70, they could see it on their screen and say, okay, I should call this guy, and probability is 20, so I shouldn't call that guy. So that's the first deployment option, and something that also works quite well for people who have a desire to keep things a little bit more separate. So the API obviously requires connectivity between machines. You can also download your model as Java code, so a code export into Java, which you could then deploy into any system that handles Java, which is very nice and low latency and so forth. And so several of my clients work with that as well. So it's telling me 1 minute, and I was also told that I should leave 1 minute for questions, so this might be a good point for me to wrap up. So basically the idea is there are more problems than there are people to solve the problems. We've tried to automate as much of the AI pipeline as possible by automating model build and model deploy, so that we can really get at the business value, which is just sitting around ready to be harvested. So that's the summary. 55 seconds for questions.
Fantastic.
Yeah.
I always love to see someone going in